As many of you will know, we've got a 4-week program in infectious disease dynamics here, which is what I'm here for. And we've organised this special lecture on a very topical subject, for which we're delighted to welcome Christl Donnelly, who's professor at Imperial College, having previously been at Edinburgh and Oxford, and whose involvement with the Badgers goes back to serving on the Krebs Committee in 1997. And she will speak for perhaps 3/4 of an hour. And then we've got also delighted to welcome Professor James Wood, who's from the Department of Veterinary Medicine here, who will throw a few questions and comments in, and will then open it to wider discussion. My own involvement with this, and I'd mention it perhaps because it gives an idea of how controversial the subject is that when the badger culling trial was set up in 1997, it was stressed that it wasn't just going to be the ministry, DEFRA, running it, but it was going to be managed by an independent scientific group. And then, as if that wasn't enough, the Select Committee on Agriculture decided that they needed some independent people, independent of the scientific committee, to check up on them, on which basis I got appointed as statistical auditor, as one of a number of auditors. And I was always expecting some further development in which someone independent would be appointed to check up on me, but glad to say that never happened. So without more ado, I invite Christl to give her lecture.
Thank you very much. Okay, does that work? Thank you very much for the invitation. Well, you'll be aware in the news that badger culling is ongoing in one of the 2 trial areas in which it's being undertaken in England. And so I'm going to talk about the science that I've been involved in and some the bits surrounding that. I'm going to leave most of the discussion of cattle-based controls to James, which is not to say that they aren't important, but just that they will be discussed later. So I thought, especially given our after-dinner speech that we had in the launch workshop, it was worth going back to smallpox. So no decisions shall be made without all the knowledge which a little analysis and calculation can provide. So there's a long history of at least striving for some link between science and policy making, but it's not a very smooth path. And so lots of people are trying, but then it's how you actually translate from the science or the range of scientific results into what the policy is can be challenging. So as Dennis mentioned, I was involved in the so-called Krebs Committee, which met in 1997 and produced a report. It was an independent scientific review and analysis of the data that was available up until that point. Essentially, there were already 2 camps at that point. One group that had said, you've been doing badger culling in various guises for decades, and TB is still going up. That means you shouldn't be doing it. You should leave the badgers alone. They clearly aren't the problem. The other group said, you've been doing badger culling in various forms for decades, and the key thing is you haven't done enough of it. So, and so they commissioned John Krebs and a committee which included Roy Anderson and myself. Simon Frost, who was here, was one of the research assistants, as was Rosie Woodruff, to this committee. And so we were to look at the weight of scientific evidence as was available and address the issue of TB in cattle and badgers. Now, the recommendation that we had out of that was that although there was compelling evidence, there needed to be a trial. And the Krebs report recommended that there be a trial of badger culling, and outside of that trial, no badger culling would take place. This was some of the press that recommendation got. Culling halt stuns farmers. Badger culling all but ended, says Krebs report. Devastated by TB's bolt from the blue. So, look, there was hardly going to be any badger culling. It was only going to take place in the trial. At the same time, thousands of badgers to die. Sort of 10,000 badgers face death in 5-year TB experiment. So, there's the science, there's the policy, there's also the media and the wider discussion to take into account here. So there are several actors and stakeholders in this process. But all of those clippings came from the recommendation that there should be a randomized controlled trial of badger culling. There was also the recommendation in that of the two forms of badger culling that should be tried. One was called proactive culling, and that involved culling across an entire area. So it's a cluster randomized trial, by which I mean that although the outcome is TB in cattle herds, you don't randomize the treatment as you might to individual patients. This cattle herd gets badger culling and this one doesn't, because they might be near each other and affect each other. So there were large areas, approximately 100 square kilometers each, and they were randomized to one of three treatments. One treatment was no badger culling at all. One treatment was proactive culling, by which I mean annually repeated culling simultaneously across the entire 100 square kilometer area. And the power calculations that were done indicated that we would need to, if we were looking for power to detect an impact as small as 20% reduction in TB risk in cattle, we would need to watch them for 5 years. So we're talking about sets of areas. So the calculation showed that we should have 10 such areas on each treatment. So that's 10 proactively culled, 10 unculled, and 10 reactively culled. Now, reactive culling is the more focused, more limited culling, which was that once TB was confirmed in cattle, then an assessment would be made on the ground of which social groups. So badgers are territorial. They live in social groups and have social group territories. So which social groups had access to the land on which the cattle had been, and those entire social group territories were then targeted with culling. So, but that was after the fact. So you found TB in the cattle, then you come back, and as a one-off cull, you reactively cull that area around that cattle herd that had confirmed TB. Now, that was an intermediate. So I mentioned already that there were these two camps, one that said there needed to be a lot more culling, one that said that there shouldn't be culling at all. And so, one could imagine if the results had shown that reactive culling worked extremely well, it worked nearly as well at reducing cattle risk as proactive culling, then you could imagine sides coming together, and even though there would be an animal rights lobby who never would agree with badger culling, it would be more people would have said, well, okay, they didn't like it, but it needed to be done, and maybe if it was done for a while, then it wouldn't need to be done in the future if a handle could be gotten on the disease, turn an increasing trend into a decreasing trend. That was not how things turned out. So this is the map of the 30 areas that I mentioned. So each of these areas is about 100 square kilometers, and they were randomized in sets of 3. So because there's a lot of variation geographically in the risk of cattle TB, and so we wanted them to be as comparable as possible. So sets of 3, and they were randomized to no culling, reactive culling, and proactive culling. As I said, no culling outside the field trial areas. The idea was that all the resources would be focused on doing badger culling in line with the protocols as well as possible within these areas, and the rest of the areas would not have any badger culling. Badgers are protected, so outside of these areas, they are by law protected and not to be disturbed, not to have their sets disturbed or to be injured or killed. So even if a farmer were to believe that his or her TB or his or her herd had their TB caused by badgers, they're not to be interfered with. And as you can imagine, if someone does feel that way, they might feel very frustrated. But this trial was to try and look not at individually, but trying to look at it at a broader scale. Now, some people, as I have found, find that very difficult to deal with the fact that we are not attributing individual breakdowns to different causes and dealing with those. I mean, ideally, you would be able to identify the root cause of a particular breakdown and tailor your response to that. But it's not possible in cases where you may be able to show that you bought a cow from a particular place and it brought a novel strain of TB into an area, and therefore you can be reasonably confident that that cow brought it with that strain with it, especially if its source herd had that same unusual strain. On the other hand, a lot of TB is not distinguishable on that level, at least the way that it's been typed to date. And so you don't know when you have TB in cows if it is recurrent TB that didn't get cleared the last time, or TB that's come in through some form of contact with cattle, or whether it came from the local badgers. But this is saying, okay, we're going to randomize those herds on a clustering basis. And so I mentioned, what in some ways might have been politically the easiest to deal with, which would have been that reactive culling was very highly effective. However, we didn't find that. We found that reactive culling actually increased the risk to cattle. And so this is a plot from the paper that we published in 2003, which found a 23% increase in the incidence of confirmed cattle TB. With an over-dispersion, there was non-significant over-dispersion, but to be very conservative, we adjusted for that, which expanded the confidence interval. And so, although it does include 0, it goes from just a 2% decrease to a 65% increase. We found these results in a planned interim analysis that was undertaken. We discussed with our statistical auditor. And we, as per our protocol, then took these results to the minister. So when we took these results to the minister, we said that our request was that the reactive culling be allowed to continue for 6 months' time so that we could have another interim analysis and accrue more data. This recommendation, and explained the basis for that so that we could get more certainty about what was going on, that recommendation was not taken up for reasons that we understood, which was once there were discussions of the potential legal implications of continuing with reactive culling when you had evidence that it was making it worse was not politically viable. So reactive culling was suspended. They didn't say stop, they said yes.
Could I just try to clarify? You've got each of the areas 8i, and what the assertion is that in each area, which is a triplet, which gets all 3 treatments, yes? The one of which is reactive culling, and then in that area, the subsequent TB is greater than expected.
Yes, compared to the unculled areas.
Right, so are we now looking at the individual area within the triplet?
So within so we're comparing so we have adjust for which triplet they're in. So yes, we're doing a within triplet comparison of the reactively culled area, their confirmed TB incidence in cattle, to the confirmed TB incidence in the unculled area, what we called survey only. And all 9 of the triplets, which are labeled A to J, 9 of those had greater than expected incidence in the reactive area. J was the only one that was different. J was the only one that had not yet had any reactive culling at all. We did include it in the analysis because as per our protocol, but it was consistent result. Yes?
Just to get it absolutely clear, the point which is plotted is the incidence in the particular area in the triplet which got reactive culling.
So it's the observed incidence per herd, yes, compared to the predicted, and the predicted depends on the triplet in which it was, how many herds it had in that area, and what its baseline incidence was. So we adjusted for those things.
Is it an incidence over the entire area, the entire triplet?
Yes.
Okay.
Yeah.
So it's like an average over the triplet?
Yes. Oh, okay, yes. So we're not comparing only those herds that had reactive culling, because by definition, those were the ones that might have been of high risk for TB. So yes, sorry, I didn't realize the issue. So yes, so we're taking all the herds that were randomized to the treatment of reactive culling compared to all the herds that were randomized to none. Okay. So this was quite a surprising result. in that badgers, there was compelling evidence that badgers could transmit to cows. The reactive treatment was removing some badgers from that system, some of the reservoir, and yet the cattle were getting more disease than they had before. So what could have gone wrong? They could have explained that. Well, one of the things that could have gone wrong is that obviously reactive culling and proactive culling, the farms and the landowners are not blind to what treatment they're getting. So it could have been, for example, that the landowners that were randomized to survey only, to no culling, went off and said very quietly, well, you know what? We don't like not having any culling. We're going to go out and do some culling ourselves. So if they actually did more culling than was done under reactive, then that might explain why reactive looked worse compared to so-called no culling. So there might have been a breakdown in what the treatment comparison actually meant if the no culling area was actually getting sort of illegal treatment by landowners who were conspiring to illegally cull badgers, but somehow without this being noticed. But it's, badgers are nocturnal. You couldn't, on the face of it, rule that out, and that was a possible explanation and one of the things put forward to what otherwise would have seemed to be a surprising result. So we undertook an additional study based on bait marking. So bait marking involves putting out peanuts and treacle and indigestible colored beads. So the badgers like the peanuts and they like the treacle and they don't mind the indigestible colored beads. They eat those down as well. So you've got a badger, so you put out a bait and you get a bait return. And so the bait returns will be distributed around the environment where that badger goes. And then if you put different colored beads next to different main sets, so underground den is called a set, and if you put blue colored beads outside this one and red colored beads outside that one and record the locations where you get bait returns, you can look at how badgers are moving around the area. And this is a sort of illustrative example of two social groups next to each other that in relatively undisturbed conditions. And badgers, studies of paternity in badgers have shown that badgers do venture from one social group to another. So it's not that they never go across social groups, and there's some bite wounding. It's sort of, there are interactions of various sorts between badgers of different social groups. But for the main part, they will tend to stay within their social group territory. So we could compare then, and I will use this low-tech pointer, the bait returns per set. And what we found reassuringly from the point of view of the trial's integrity is that the bait returns per set, which would be a marker of badger density, were lower than the no culling areas. So the result did not occur because the no culling areas were actually, quotes, no culling areas, but were actually being heavily culled by landowners or their agents. So that was reassuring that the trial, I'm not saying by any means that there was nothing going on in these no culling areas, or indeed that there had not been illegal culling going on in some of the reactive or proactive areas as well. But just that in relative terms, that was not culling, illegal culling in the no culling areas was not responsible for the reactive result. But what we also found was that the median bait return distance, so how far badgers were roaming, was significantly greater in reactive areas compared to no culling areas. And you can see here where there are stars, which represent the location of a main set, and then you can see little points, so polygons drawn around the baits that come from a particular main set. It was impossible to do colors here. This area is very dense with badgers, so this is a no culling area, so you see more bait returns across this area than you do where there's been some reactive culling. But what you also see is that for the most part, these social group territories don't overlap too much. They look like polygons that don't overlap a lot in most cases, compared to reactive culling, which has fewer bait returns, but you see a lot of overlap. A lot of these polygons are overlapping each other, so you're getting badgers at least taking it, we can't say for sure where the badger came from before the culling, but you're getting much more interactions across the spatial span of different badger sets. So that's one insight we gained from the bait marking study. The other was to do with proactive culling. And in proactive culling, we also looked at the bait return distance and the density or the number of bait returns. So imagine this dotted line is the border, that's the outside border of a proactive culling area. As you move to the right, you're going inside. So these are in meters, so that's 3 kilometers inside an area. And as you go to the left, you're moving outside. So what we see is reduced badger density, so this marker of badger density, which is bait return, so reduced badger density inside the proactively culled areas, which is what you'd expect if you did proactive culling. But we see a trend as you go up to 2 kilometers outside the proactively culled areas. Now this study design was due to Rosie Woodruff, the badger ecologist on the independent scientific group that undertook, so we designed, analyzed, and interpreted the trial. She said, well, badger culling on the scale that is being undertaken in proactive areas is so large that we should look up to 2 kilometers outside the area to see what impact it might be having on badgers out there. And you see, you get a significant slope there. So badgers up to 2 kilometers away appear to be affected in terms of their density. So, you know, if this was the default density, you can see it going down as you get nearby. And also, you see greater bait return distance, so wider ranging inside the proactively culled area, and again, a significant slope as you go from 2 kilometers away up toward it. So badgers up to 2 kilometers away have their behavior affected and also the badger density affected, which suggested to us that we better look at the cows up to 2 kilometers outside our proactively culled areas as well, which was not in the original protocol. And so, going forward to 2006, we came out with the result of within the proactive culling areas, so taken as all herds in those areas compared to all herds in the survey-only areas, they had a 19% reduction in risk, which was highly significant. And so we demonstrated in this randomized, controlled way that badger culling could reduce the risk of confirmed cattle TB. But as I mentioned, we also looked outside. So when we looked outside, we took the farms up to 2 kilometers outside proactively culled areas and compared them to make sure we had like with like farms that were up to 2 kilometers outside unculled areas. And that's important because we specifically put trial areas in areas of highest incidence. So when I want to compare like with like, and there we found a significant result as well, but it was in the other direction. A 29% increase in cattle confirmed TB. So now, as I mentioned, you had the two groups that were on opposite sides even before the trial, and now we've ruled out reactive culling as being a worst case scenario in terms of some badgers get culled and cows have an increased risk. So then these results either push you toward not culling the badgers, or if you're going to cull them, culling them over large areas. And in relative terms, the area up to 2 kilometers outside will be smaller if you have a very large culling area. Also, of course, if you could use sea boundaries. So if you had sea boundaries, then you have relatively few herds that would be in the areas up to 2 kilometers outside. But unfortunately, so the gray here represents, in some sense, at that point in 2005, the variation in local risk. So the one, which is testing every 1 year, is the highest risk. And you can see that in the southwest and Wales, it was already by 2005 quite widespread. And so not in small patches that you can imagine easily taking out in that way. So those results, so the trial results up until the time of the final report of the independent scientific group, the ISG, combined with the cost. So what we found was that even if you ignored, so that, again, like the reactive result, the outside detrimental effect was controversial in some ways. But we found that looking at the costings, which had been, so data on costs had been collected by what was originally MAF, the Ministry for Agriculture, Fisheries and Food, and now DEFRA. They collected data on costs of culling, and we found that the cost of undertaking culling outweighed the financial benefits of the reduced cattle disease inside culling it. So even if you ignored the detrimental effect outside, the cost was more. That was based on the method that we used in the trial, which was cage trapping and shooting. So cages were baited, again, with peanuts, set to trap late in the evening. Badgers would come out, go after the peanuts, be trapped inside, and then they would be humanely shot at point blank range at dawn. So spend the minimal amount of time in the trap as possible, with regard, with health and safety issues that you couldn't have people trying to do that at night while they might be disturbing other badgers that were going into traps. So there were now in this, the costs involved, I mean, badger trap is a big thing. So even a big guy can only carry one. And so laying these around. So one of the alternatives is to do snaring. Now I'm told that the same big guy can throw a lot more snares over his shoulder and carry them around and put them out. And that's what's done in Ireland, is snaring is used. Snaring is seen as not being socially acceptable in this country. So snaring was ruled out as even a possibility. But as we said here, so including an economic assessment, we conclude that badger culling cannot meaningfully contribute to the future control of cattle TB in Britain. So that was what was said in June 2007. Now that was not universally the view, and I got called on this about 11:30 in the morning on the morning of the 22nd of October, and told, we're about to announce it to the press, but we wanted to give you notice, which was about half an hour or an hour, that the David King, the independent scientific advisor, has conducted, with a committee, has conducted a review of the ISG findings and has come to a different conclusion. This will come out at midday. And by the way, tomorrow when you're seeing the Parliamentary Select Committee, he'll be there as well, which was a surprise. Because we hadn't been told this was going on. So we had our final report in June, and then we found out in October that this review had taken place. So he and his committee urged that a badger cull take place, and there were, the key issues were that he didn't think that as scientists we should take into account economics, that we had overstepped our remit. We pointed out that in that respect, that DEFRA had actually approved when we co-opted an agricultural economist onto the group after it was first founded, because we felt that that was something we needed, and DEFRA hadn't told us then that was outside of our remit. But David King did. So that was one of the reasons. So if you didn't take into account cost, then you might come to quite a different conclusion. The other thing was he's very skeptical of the outside effect. And so this is one of the graphs that we had produced. So this is looking at the distance, again, inside and outside the proactive area. So again, as you move left, you move further outside a proactively culled area, and above the line is making it worse. And so that's detrimental. Below the line is beneficial, and as you move this way, you go inside, toward the middle of a proactively culled area. And so this was a subgroup analysis. It wasn't the main analysis, but it was a subgroup analysis. So, but this is what they said. So we consider the ISG's views that this benefit, that's a benefit of the inside culling area, was largely offset by the increase in incidence outside is unsound. And this is the paragraph where they talk about it being unsound. The confidence interval for the detrimental effect outside the removal areas are very large. 3 out of 4 go through 0. So 3 out of 4 of those subgroup analyses, the confidence intervals include 0. What this didn't use the same reasoning for was all 5 of the inside ones included 0. So there was a different approach taken to the benefits, which was to accept the result without looking at the subgroup analysis and picking it apart. David Cox, Sir David Cox, the statistician who was also on the ISG, said afterwards that he wished that maybe we hadn't put confidence interval on the subgroup analysis, that this was supposed to be showing that he felt that confidence intervals in this were misleading, and that the point was not whether or not they included 0, the point was to look for the trend, in which you can see a clear trend as you move inside. There appears to be a trend. It's actually non-significant that you get a bigger benefit inside, but just from a logical point of view of how the system might work, you would think you would get more benefits deeper inside a large culling area. Anyway, so we had then a meeting in December just before Christmas where we all came into one room and discussed the things that we agreed and didn't agree about. And actually, except for the issue, we seemed to discuss this issue of subgroup analyses and largely resolve that to the sort of, okay, we mostly accept the same science but come to different conclusions, and you shouldn't have considered economics, which is obviously for the policymakers to consider further. Then in the middle of 2008, a decision was finally made, which was then by Hilary Benn, the Labour Agriculture Minister, who then rejected the idea of badger culling. On the basis, 1, I think, of cost, and 2, the risks that if you didn't, considered alternatives and felt that what we'd shown with reactive culling was if you didn't cull systematically across a big area, you could actually just make it worse for cows, and therefore alternative measures that were considered then of different forms of culling would have a risk of making the situation worse. The issue also that it cost more than it was saving. So, but if you were, imagine you were a minister, and at the point of the final ISG report, you were just right on the edge of should you cull, should you not cull? Well then, if that was you, then what has happened subsequently would mean that you would be thinking that you should cull. Because what we found, this is the time while culling was ongoing, between first and second cull, there's not much impact inside, but you see a suggestion of a detrimental effect outside. The detrimental effect as culling goes on diminishes. The benefits become larger. After culling has stopped, in this 18-month period here, you see about a 50% reduction in TB inside the unculled area. So this post-trial period starting from here, which is labeled then in months, is more than a year. Because the culling was happening in annually tested cattle, we had to wait more than a year after the last cull before we could really be post-trial. And so you find that you get bigger benefits thereafter, and then they appear to be gradually diminishing. The effect outside, certainly the detrimental effect, there's no evidence of there. That appears to be maybe it's actually a benefit outside in this red after culling stops, but then it bounces around. So the final estimates of this time period are 4% lower outside. This is for the post-cull area, taking all that into account, which is indistinguishable from 0, but a 28% reduction over that whole time period. That's over 5 years inside. So we go ahead to the election, and we get the Conservative Manifesto. We will introduce a carefully managed and science-led policy of badger control. Now, it was interesting because I was contacted about this once this came out. One question was sort of, well, whose science will that be? Will that be your science or David King's science? On the basis that you could use, you could point to a scientist and say, oh, we're science-led. And the other thing was, they said control and not cull, and they must know the word cull. Therefore, did they mean vaccination? but they're trying to be cagey, hoping that everybody will read into it what they want. If you wanted vaccination, you'd read that and say, oh, they must mean vaccination because they didn't say cull. And if you wanted a cull, you'd look at that and think, well, okay, that's the obvious way to control them. So I'm not sure what the basis of the decision of how that was worded was, but that was how it was put. And so I mentioned, and this just puts a quantification on it, the idea that the larger you make the area, this is using estimates inside and outside the culling area, up to 2 kilometers outside, and for different size circles of culling area. And these are in terms of square kilometers. So taking into account the effects inside and outside during culling and post-culling, then you see that with a 95% confidence interval, 100 square kilometers is actually just about the break-even point. And so, but as you get to larger areas, you become more statistically confident of getting a net benefit. Now, point out that is a net benefit because the estimates would indicate that the farmers on the outside, as a group, will have a net increase while culling is taking place, not afterwards. But the inside, that they would see a net benefit. They would see a benefit both during culling and after. But that gives an indication. It just quantifies that one, that no matter how big you get the area, on this basis, and this is a simplified basis because we're not taking into account in this sort of population level effects. So this estimate is based on purely algebra of weighting those different effects. And so we're not talking about, well, therefore, if you impact the cattle in one area this way, when they get traded to other areas, then they might have reduced risk. But it gives an order of magnitude for what the overall effect might be. In addition, I was involved with Jim Hone in developing a simple model so subscript B is for badgers. These are infected badgers over total badgers. These are cattle herds, infected and total. And so you can set up a very simple model for the relationship between apparently infected badgers, or detected infected badgers and infected cattle, and fit that to data from the initial culls. So you can, if you fit that model, then you get this point, which does a reasonable job of fitting these data points. It's not perfect by any means, but you see an increasing trend, and this allows you to estimate what, according to this model, which was fitted to data from the initial proactive culls, that's why there are 10 data points, what would happen if badgers weren't contributing to the system at all? Because that's the interpretation you'd get with a 0 infectious badgers. And the central estimate suggests that there would still be TB in badgers. However, it was not significant. Not only is this a simplified system by far, but also, even if you believe this system fully represented it, we can't significantly rule out that this actually goes down to 0. But it does allow you to do something else, which is you can look at, for a particular level of badger prevalence, what you would predict the badger or the cattle risk would be by going across. And then you can compare it to what it would be. So, so here's the total. And this would be the component that you could say was due to badgers in that particular triplet. And this is the component that's not due to badgers. And then you can weight those over all 10 areas and get an estimate of what that would be. And the estimate was 50%, like 49.9%. So this is exactly the same result. If you correct for the fact that so I just mentioned infected badgers without pointing out that was on the basis of the standard postmortem that was done in the trial. In fact, standard postmortem was shown compared to an extended postmortem to have a sensitivity, this is within the badgers, of only 50%. So the prevalence was actually twice what we originally thought. But it doesn't affect my 50% figure at all because it merely stretches it horizontally, that graph. So you still get the same estimate. Now, DEFRA produces graphics. They have some fancier word than graphics. About facts about TB, and they put their the 50% estimate in there, and linked it. So it was derived from the paper with Jim Hone, but then I did some additional algebra, which is there. And so then, but this is out. So then it gets commented on that the so 50%. It's estimated 50% of herds are due to badgers. They wanted to know if it has been peer reviewed, and then they said, "Oh, it's from @Christl Donnelly," carefully handing that over to me. And so then I said, "Okay." So I said, "It's a calculation from this paper," and so they said the read in full. So then they point out that I'd said it was from observational data, and it was a small data set, which is, of course, true. And then I said, "Well, you couldn't demonstrate this experimentally, but we used all the data that were there. And given this, are you comfortable with DEFRA using the statistic as the key argument for the badger cull?" To which I would say that it isn't the key argument for the badger cull, and I don't think DEFRA are presenting it that way. They are presenting it as a motivator to need to do something about the badgers. But what you do about the badgers then is a separate issue. And I want to point out that although that is one calculation which has a wide confidence interval, you can look at this period, which I mentioned, this 18-month period, where you have a central estimate of a 50% reduction in TB inside the culled area, which has a 95% confidence interval from 38 to 66. The impact of culling must be limited by the proportion due to badgers on this level, on this scale, and therefore this provides a sort of lower, this would be a biased estimate, you might think, in that we wouldn't expect proactive culling to reduce it all, but the lower limit of that could be seen as a lower limit on the estimate of the proportion of cattle TB due to badgers. I'm going to skip the national trend. There's obviously protests and campaigning in the public debate. I just wanted to point out quickly the comments that have been made. So John Krebs has been very prominent in calling it mindless. And Robert May has also been a critique. It is very clear to me that the government's policy does not make sense. John Beddington, who was the chief scientific advisor at the time that the decision was made, said his comment in this article was, "I'm content that the evidence base, including uncertainties and evidence gaps, has been communicated effectively to the ministers." So it was all explained to them well. And I would point out to people that if you're interested in further details, that there was a consensus exercise which included James, and we produced a document which was then published in the Proceedings of the Royal Society, which is a restatement of the natural science evidence base. Obviously, there are social science aspects of this, but we went through sort of looked over all the scientific evidence we could find relating to TB in cattle and badgers in Britain, and tried to summarize it there. And I'll end by pointing out, so the current state of the science-led policies are that in England, as of 2011, they proposed farmer-funded culling. So your cost-effectiveness issue changes if you say farmers pay for it themselves, although they don't pay for the policing. But also they changed to allow a different form of badger culling, which was the shooting of free-ranging badgers. So controlled shoot. So people, I don't know the exact method in detail, but it involves going out with a firearm and a light to try and look for reflection from the eyes. And then if you're an expert marksman, you should then be able to identify if it's a badger. But obviously there are particular risks in terms of health and safety if you have protesters out and about, and also potential concern that a badger might be shot but not immediately killed. And so there are now 2 culls that are to be undertaken, one of which has already started, and you've seen in the news, another of which is rumored to be starting very soon. There are protesters out there as well. there's an independent scientific group that has been brought to look at the effectiveness in terms of how much the population was reduced using this alternative form of culling, and to look at the carcasses of 60 cage-trapped and 60 free-ranging shot badgers to look at the humaneness of the way in which they were killed. In Wales, they moved from a government-led cage-trapping badger culling operation to a government-led badger vaccination across a large area. So they have a very large area here that's undergoing badger vaccination. So that's injectable vaccines being undertaken. And I will end by thanking my ISG colleagues, which include David Cox, which many of you may know, who I've already mentioned, but there are other groups as well, so other members as well, including John Bourne, the chairman, and Rosie Woodruff, the badger ecologist. Okay, thank you very much.
Thanks very much. So, yes,
Can we wait for questions?
Well, has anyone got any immediate burning questions? Otherwise, I think we might take questions for joint session. I was going to say, the last photograph reminds me that the proudest boast on my CV is, in terms of teaching whatever, is to have supervised Christl and David Cox, which David is not so knowledgeable about statistics. I think he's reckoned to be one of the great statisticians of the 20th century. Still alive and well, I'm happy to say, and still working. So, Professor James Wood.
Yes, thank you very much, and thank you very much for the invitation to speak to you, but also I understand people as far as Edinburgh at least, and maybe further afield through the wonderful Institute web streaming. No one warned you about that. Dennis asked me to add something on the cattle controls in bovine TB, because I think that you could be forgiven reading the media debate around the control of TB, that actually it's badgers or nothing. And in fact, there are really stringent ongoing cattle controls. But we're talking, what's being discussed or proposed with badger culling or badger controls of any nature is as an adjunct to cattle controls. So I'm going to talk through a little bit of the background of this, touch on some of the challenges, and try and bring things around a little bit at the end to seeing how both of the things link up. So what I'm going to do is gallop through a bewildering plethora of information that exists in relation to cattle controls. And if you think things are confusing in terms of whether or not badger controls work, it's even worse for cattle, particularly in relation to the specific controls, not least because there's never been any randomized controlled trial of specific cattle measures. And so there's a lot of inference from observation or fitting to data. So the historical perspective and why this is important, although the reasons don't stand up today given pasteurisation, is that we used to kill 2,500 people a year due to bovine TB, or what was almost certainly bovine TB, when you go back into the 20s and 30s. That started to be addressed with voluntary schemes in the 1930s, and then in the 1940s, after the Second World War, we adopted the standard diagnostic test in cattle, which we still use today. As a result of voluntary uptake of the attestation scheme, which was a parish level scheme rather than a herd level scheme, the cattle slaughtered due to TB in these attested areas, and the complication is that the area that was attested expanded over this period. You can see that as the proportion of herds increased, the incidence of TB in those areas at least came down, providing some evidence of the effectiveness at one level of TB control. Now, when towards the end of the 50s, around 1960, when all herds had to be tested annually for TB, there was a very high incidence of bovine TB in terms of reactors slaughtered. And the basic control in cattle is to test at a frequency, depending on incidence, in the background area, and to slaughter those animals that come up positive in the tested herds, to put those herds under restriction, and then to repeatedly test them until all animals in there are clear, and then to release those with more detailed follow-up testing. So in any case, it seemed that those cattle measures were very, very effective, and on annual testing. There was some reduction in testing instances we got into the 1970s. Then when I was a student, a vet student in the 1980s, bovine TB, other than a small area in Gloucestershire and West Sussex, was not anything you had to worry about. It was more or less disappeared. And I think perhaps because of inappropriate culling of badgers, or perhaps that combined with what we now know is inappropriate culling, perhaps, and also combined with people taking their eye off the ball because they thought it was under control, the outbreak, the epidemic started to take off again towards the end of the 80s, such that it had reached a reasonable high incidence until at the end of the 90s and into 1990. Now, one of the best measures of the effectiveness of cattle controls is looking to see what happened in 2001 when all testing was suspended for, I think, a 6 or 8 month period, and it nearly doubled. And so that's what happens when you stop testing and removing cattle. And that was at a period when nearly the whole country was under movement restrictions. So this is talking about the instance of cattle in cattle, not really related to cattle movement between farms. And it's remained high since then. So that's cattle level measures. You can look at the standardised herd prevalence, and although the results are very confusing because if you look just at the instance in the annually tested area or the high instance area, that has spread geographically massively over the period. So it's a little bit confusing to look at the instance in that. And you might say, well, what we need to do is look overall at the instance in England, but you can see there's a large increase, even though some parts of the country weren't affected due to the expansion in the areas that already had TB. But then you can see that the instance has, at least up until 2010, had a pretty steady increase. Now, the bovine TB surveillance in Britain has two components. Every animal that goes to be eaten is visually inspected, and you can see, usually not as, I mean, we always show the worst picture in a talk like this. Often it's a very small lesion in one lymph node, one gland in the respiratory tract. But that's a very important method of detection of cattle infection, particularly in areas which are only being tested every 4 years. And then there is a skin test in live animals, which is undertaken either annually in high instance areas now or in the low instance areas on a 4-yearly basis. This is the sort of bewildering follow-up of different test types that follows the diagnosis of an infection, whether it's on a routine or whole herd test or detection in the slaughterhouse. The slaughterhouse case is detected back to the herd of origin. And then, as a result of that, there are follow-up tests during the breakdown, which are conducted every 2 months. Depending on whether or not the infection can be cultured from these organisms, from these animals, different levels of severity of interpretation of the skin tester are used, and I'm not going to try and explain them all to you in this period of time. And then once 1 or 2 clear tests have been had by the whole herd at a 2-monthly basis, then there's an extended 6 and then 12-month follow-up test before they revert back to annual testing if they don't break down again. So as I said, the abattoir surveillance is very, very important, particularly in the low incidence areas. In fact, over all the country, last year, around 20% of all breakdowns were detected in the slaughterhouse in animals where the infection was not detected. Very complex previous designation of areas as high, low or medium incidence, and so you can see the red is the high incidence, the light yellow is the lowest incidence, with blue and orange halfway in between. Really quite confusing. There's a confusing movement of areas between these different levels. That's changed. The other thing that's changed even in the last 10 years is all of these introductions of new tests or changing the way the tests have been introduced. And a key one that I point out to you is that all animals moved from herds in high instance areas, in these annual testing areas, now have to be tested within a 30, I think it was a 60-day period, I think it's moving to a 30-day period now, before they can be moved onto other herds. And so the cattle measures have sequentially got tighter and tighter and tighter over this period of time. But you can see, if you're trying to interpret what effect all of these have had, with very crude, annually tested figures that are all that you've got coming through, it's very, very difficult to determine what's effective and what's unnecessary, or what's not really having an effect. But the DEFRA analysis of the way the instances increased from 86 through to 2000 and then afterwards is that the doubling time of the epidemic increase has diminished somewhat, albeit with rather broad confidence limits after 2001. Things have got much simpler this year. We now have a 1 and a 4 year testing area. And with a key focus on the edge area to try and stop further geographic spread. And the aim of this new strategy is to try and make sure that with a focus of the controls in the high incidence areas where the major costs are, to try and eliminate bovine TB as it's been pretty much eliminated from Scotland in areas like northeast England where there's very low incidence of infection. But the major challenge to cattle controls and cattle herd breakdowns is persistence on the herd. And there are two measures that you see with that, with this rather crude testing that's undertaken in cattle. Firstly, that around 30% of breakdowns are extended beyond 240 days, despite the fact that because of the fact you've got this repeated testing continuing to find infected animals. And the other issue is that you get a very high rate of recurrence of herds once they've been released from controls, apparently clear of infection, and such that within 3 years of release, 50% of those herds are breaking down again. Now, it's not clear whether that's due to persistence in cattle or wildlife or reintroduction by cattle movement, but it's a very major challenge. Now, I'm not going to take any longer to describe the details of this. Andrew Conlon, working with a group with TJ McKinley here, fitted two very extreme different assumptions in relation to latency, epidemiological latency in cattle, to pretty complex herd size dependent data looking at prolongation and recurrence at 6, 12 or 24 months after breakdowns had taken place using using approximate Bayesian computational methods. The conclusions from those two really extreme measures were that either 50% or 25% or so of recurrent herds were due to a missed infection within those cattle herds. And this is a measure of how important cattle controls are, another measure of how important cattle controls are in the control of this disease. In the vast majority of herds, the only one animal infected was estimated to have been left behind. Now, it's unclear what the contribution of these missed infected animals, which are then released, and there's a lot of movement of animals after release because farmers then can finally start trading again, what contribution they make to between herd transmission. So one question that I would ask is whether there's a threshold effect that we need to take into account with this particular disease. Ellen Brooks-Pollock here, looking at taking a demographic approach to the instance data available, a really exquisite instance data available from cattle, has estimated in different herd types the R0 value to be very close to 1. In Andrew's work, even uncontrolled TB, simulated, was estimated in small herds to have an R0 value of 1.5. And I think that the question that I'd ask from that is whether even small changes in regional instance, such as through badger controls, could actually have a significant impact. I'm not going to jump through those two herds. And one question I just want to ask is, and Christl touched on it at the end of her talk, is if after you've killed a lot of badgers in an area and you see a 50% reduction in the incidence of the disease in cattle as a result of killing a lot of those badgers, I think we have to be cautious in saying, although there's an independent estimate that Christl's produced to suggest that 50% of breakdowns are probably attributable to badgers, I think we have to be careful to use that figure directly to say that probably that means that 50% of breakdowns are directly attributable to badger infection, because after that period of time, I think the lower incidence in cattle may feed through to a lower incidence in badgers. And the one area where we have no knowledge whatsoever is how important, how rapid that rate of transmission is from cattle to badgers in these high incidence areas is. And so this is where I think one of the key deficiencies for us as a modelling community in relation to what we have not produced is a two-host dynamic model to actually try and capture these effects properly, so to really understand the dynamic between this two-host model. And that's only important, though, in the high incidence areas. In the low incidence areas, there is really little evidence of any spread other than that's been posed by cattle movement. Thank you.
Christl could be put on the platform. We have some time for questions. But I suggest that maybe if anyone's got technical questions, we start with those and move on to the policy ones after that. So if any sort of technical questions
Well, I suppose this is a bit technical. The background information, I'm moderately ignorant about all this. So the background information did basically state that whether TB is transmitted from cattle to cattle or badger to cattle, it can be transmitted by deposit pasture. Now, therefore, when you find a herd which has cases of bovine TB, that suggests that the pasture that herd was on is contaminated. Is anything done about that? Is it taken account of in?
Nothing is done about.
So
nothing is done
back in the same pasture.
Nothing is done about it directly, and to be fair to the farmers, there's very little that you could do about
Of course,
that.
yes.
I mean, I think that if you're convinced that the infections come from badgers, there are sensible measures such as trying to fence off badger latrines. They're fairly clean animals that tend to poo all in the same place. So if you can stop badgers grazing those areas, then it's logical that you should be able to mitigate the risk from them. But we know very, very little about the environmental spread of this infection, or residue of this infection. But I think it's very interesting that if you look just specifically at the effect of vaccination in badgers, some work that's recently been published, vaccination of badger sows, badger mothers, can have a really quite surprisingly strong and positive benefit on the rate of disease in their badger cubs coming through for that year, suggesting that the residual infection that you have in those sometimes very heavily infected areas or environments isn't enough to cause widespread infection in animals, even after you might expect maternal immunity to disappear. So I think that it's quite a big area of uncertainty, but there's no strong positive area to suggest that residual infection around the farm is really important. That I'm aware of.
Yeah, just going back to your slide showing the doubling of incidents in, I think, 2001. This is a clarification, really. You said something along the lines of how that demonstrated what happened in the absence of cattle movements. Yes. But my memory is that after the epidemic finished, there was intense movement when farmers restocked. And so, what time period are you really talking about when you say that?
So a lot of the restocking occurred around that time. That's a fair point, and there was certainly spread to a lot of areas of Cumbria in farms restocked from the southwest, where there's a very high cattle density, so it was easy to buy replacements to restock farms that had been culled due to foot and mouth disease in 2001. But there was also a marked increase, which isn't shown in that overall graph. There was a marked increase even on farms that weren't restocked. So yes, there's a restocking bias there, and I'm sorry I should have pointed it out. But there was also a significant impact on farms where there was not restocking.
This might be your non-technical section, but looking at DEFRA statistics, which are very sparse actually on TB and other types of wildlife, it's very obvious that deer, cats, pigs, all kinds of animals can pick up and transmit TB. Cats are quite interesting because they're obviously quite, they wander around a lot. So Is it right that so much attention is being devoted to badgers when there's clearly a risk of infection by other means?
So the cat and deer data are interesting, and the pig data as well. I think in pigs and cats, the prevalence of infection reported on those DEFRA stats is around 19% of all of those animals that were investigated. But that's not surveillance data. It's not passive surveillance data of all animals or of a survey. These were animals that were only tested because they were suspected to have DB. And so it's not a statistic that gives you any insight into terms of what's happening across the country as a whole, if that makes sense. And I think that there's clear evidence that deer can get infected, but there's no. I think that the evidence that Christl presented, demonstrating that you can have in the time after culling of badgers in a randomised way, so you could remove the possibility of biases other than interventions that weren't meant to take place. So you have a 50% reduction associated with that. Demonstrates the preeminence of badgers. That's not to say you can't have some farms where transmission comes from deer, or potentially that you might get a residual infection in the cat. But at the population level, I think given the fact that this is an infectious disease of cattle, and 50-ish% in high incidence areas may come from badgers, I think that the suggestion that other species can be playing a really important role in transmitting or persistence of infection at the national scale, I don't think they hold much water, if that makes sense. I mean, it's an interesting point, and there's a sparseness of data there, but I think that it's absolutely sensible that you focus on the things where there's a really strong effect, and there's a very strong effect in terms of transmission from cow to cow that needs to be addressed. And there's very strong evidence of a very important role in the high incidence areas for badgers being really important. Now that doesn't mean to say, as Christl said, that culling is right, but it does mean to say that if you want to address the problem of TB, you probably need to do something about that.
Question for Christl. Are there any controls for badgers that focus on taking out the whole social group in one go, rather than just random badgers? And if there are, why aren't they focused on a bit more?
Well, the reactor was designed specifically to try to take out the geographically implicated badger groups, which wasn't necessarily to say that even they were necessarily the source of the TB infection in cattle, but also could potentially have the protective effect that if those cows with TB had infected some badgers, it would most likely be them. And certainly the design of it was made to specifically try and take out that social group as much as possible. But we know from various estimates that we got on the order of about 70% reduction in badger density with widespread culling. So, targeting a particular social group, you'd be hard pressed to get just those animals and not the other ones, because you'll have animals coming in from exploring more widely much immediately as when you start culling. So
is that what gassing did when they used to, or whatever they used to do in the 70s? Would that presumably take out a whole social group?
Presumably, you have the possibility of that social group members may be in different sets, but let's say you were particularly fastidious and managed to find all of the badger sets that were there and block up all of the entrances and then gas the badgers that were in there during the day when they should all be sleeping. In theory, then you could do that. I mean, the gassing was stopped because it was found to be ruled to be inhumane. Various people resisted.
The killing of other wildlife inadvertently as a result of that, with methods being used then.
So, people have since suggested in various discussions that there might be alternative gases that would be available that might be not seen to be the same level of inhumane. But that's a very high-level policy decision that needs to be made. But the reactive cull was given the best shot from an ecological point of view by trying to target the social groups, and that distinguished it from an interim strategy which only put traps on the reactor land. So they brought those big traps, put them out on the land on which the cows had been, and said, well, okay, we'll just get what badgers get trapped there. And so that wasn't trying to do the best at just taking out those social groups, but it's, a sort of surgical strike is very difficult.
So I suppose we don't know anything systematic about the present culling strategy. I mean, it's presumably it varies from area to area, but it's clearly devoted, fairly clearly. So it's taking out individuals who can be found at night by a marksman going out looking for badgers. So it's likely to be.
Yeah.
As Christl said, trapping's being used as well as free shooting.
Right. Okay.
And mostly with a rifle.
But again, this would probably be going for relatively random individuals rather than particularly social groups.
I mean, for
But I suppose it might be very localised. I mean, I suppose one shooter might just think, I got a couple of badgers here the other night, I'll stick around and get more in this area, in which case they might
That's exactly. I mean, I think you could
take out a social group.
I think, I mean, if you talk to farmers, they're often blissfully unaware of where badgers may be on their farm. But those that have more take more interest in the environment around them often have a very good idea of where the badgers on their farmed land can be found. So, and obviously, if the farmers cooperating with that culling, you'd expect them to be talking to the people doing the shooting in terms of trying to help them do that.
Other question, so question perhaps for Christl and for Rosie Woodruff if she was here.
channel
Would be actually whether taking out social groups as opposed to taking out a sort of fraction of each social group, which of those is going to help control the TB? Because you might argue that actually taking out complete social groups is more disruptive because that immediately inspires the other groups to come and fill in that vacant territory, whereas if you just cut back the family size, they may just sort of retreat more to their own social area and not interact with other badgers as well.
Yes, I don't think I can channel Rosie on that.
But would you?
I think an interesting and important underlying question in relation to the efficacy of badger culling is a rather complex interplay between the instance in the badger population that's being culled or has been culled in previous times and the reduction in badger numbers. A key impact of the reactive culling and Christl will want to comment on this as well, and the current policy. It's about reduction in badger population numbers. Now, I think what was found was that the incidence in badgers that weren't killed actually seemed to increase. But and so that that's and despite that, the incidence in cattle came down, suggesting that the density dependence of the transmission might be really important. But I think, and whether that underlies some of the reduction in the around the culled area. A reduction after culling is finished, I think is an interesting speculation, but I don't know if there's any data on it.
No, I mean, the difficulty is in order to get estimates of the badger prevalence, the badgers have to be killed. So we specifically don't know what the prevalence of badgers is in the 2 kilometers outside the proactive culling areas. But what we do know, as James mentioned, is that on subsequent culls, so later reactive culls in that targeted the same area, or proactive culls that were later, we found increased prevalence as opposed to the initial cull. So my mental model is that whether or not you're dealing with inside the proactive area, in a reactive area, or outside, in the 2 kilometers outside a proactive area, you've got this complex trade-off between a reduction in density, change in behavior, and then the resulting impact on prevalence. So if proactive culling has shown that if you drastically reduce the badger density, you get a net benefit to cattle. So even though the prevalence is higher in the badgers, it's still better for cattle because the density is so depressed. But then you get the detrimental trade-off up to 2 kilometers outside, and obviously in the reactive culling.
John?
My question is about the geographical distribution of infectious hotspots. Is there a correlation, or is there anything known about the distribution of badger populations relative to the hotspots in the country? And is the prevalence of hotspots in the west possibly climate related, rainfall related, temperature related? It's colder and...
Actually, I've got quite a quick answer to that. I don't know, but I think that one point that I would make is this graph shows that the geographic spread and the increase in the incidence of the spatial incidence of bovine TB from the mid-80s through to 5 years or so ago, and I'm sorry that those figures are a bit out of date. If you look at the cattle density, you can see that the greatest density, rather crudely, even between the mid-90s and the mid-noughties, is much higher in the west and the southwest. So a point I'd make is that even if you've got lots of badgers up here, you haven't got very many cattle for them to infect in East Anglia and other parts of the country. And although there are plenty of cattle and plenty of badgers up in the northeast of England, but we've got no TB, and so there's it's somewhat of a it's not really a chicken and egg situation, but I mean you can get away with having loads of badgers and cattle without obviously the infection being there, and I think that's a really difficult confounder. And I don't believe that we really understand or have enough information to answer that question, but I do think that the DEFRA should have just received or be about to receive a recent update on an estimate of badger numbers in different parts of the country, which would be an update, the most recent update from the figure that was the survey was last conducted in about 97. Yeah, and so it's something we've got very, very poor data on. I mean, obviously we know quite a lot about rainfall and temperatures and so on, environmental variables across the country, but there's a lot of missing data on the wildlife side of things.
So building up a little bit of a queue of questions, 1, 2, 3, 4, please. First one.
Can we learn anything from the situation in Ireland, where so you show here that the cattle density is much higher, and you showed in the previous graphs, the James showed in previous graphs that the incidence of TB on number of new cases seems to be quite high. Whereas you, Christl, mentioned that different strategies have been used there for badger control.
Yeah, so in the timeline that I was presenting, in between the reactive cull result coming out in 2003 and the proactive result coming out in 2006, there was publication of the 4 areas study, which was a study looking at 4 areas that had culling compared with 4 unculled areas. They weren't randomized though, which was a bit of an issue about it, but they did those comparisons. They found, gave estimates, they didn't give a central estimate because they varied so much, but they reported impacts on cattle risk of reductions between 60 and 96%. And the 96% actually was not representative of more than 1 year as it was originally reported. But the interesting thing in looking at that, and so there were immediate calls from some porters that well, we don't want the RBCT style culling. Obviously, we want the Irish style culling. But they removed, even though they had this method of setting out snares, which is widely believed to remove a higher proportion of the population of badgers, they removed fewer badgers per square kilometer than we did with proactive culling, which suggests that even the density is different. And because badgers are social creatures, if you change the density, that may have impact on their social behavior as well. So it's quite difficult. I don't know.
No, I mean, I think that's absolutely right. And I think one of the problems of extrapolation between Ireland and England or South Wales is the really different badger density between the two that could have a profound effect. But I think that I think we'd be foolish also to ignore the fact that the Irish government are now claiming, I think, something like a 50% reduction in bovine incidence, although the figures aren't properly published yet, as a result of their introduction of their badger culling by snaring.
Yes, just a quick point of clarification, which is, what do you perceive to be the incidence of TB in badgers, and where are they getting it from? Yeah, have there been any DNA studies, for example, looking at whether it's coming from particular cattle herds or?
Well, there are studies that have shown that so it's not genotyping in the sense of actual sequence. So it's more crude spaligotyping, or there's the NTR. But I mean, just alternative ways of typing. So you can do that, and what you find is that you get clustering, geographic clustering. But what you can't prove with that is direction. So badgers with a particular spaligotype tend to be closer to cattle with that particular spaligotype. But that doesn't tell you the direction. In terms of prevalence,
Actually, I think it tells you that it's going in both directions. We know it's going from cattle to badgers. Given the very tight clustering, I think that tells us it's probably going in both directions.
but you can't tell for a particular individual.
No, absolutely not. No, but in ecological terms, I think we can assume, we don't know the rates that it's going in both directions, but I think that we can assume that it is, at the regional scale, going in both directions between cattle and badgers because of that.
So what's the range of incidence in badger populations?
So, well, there was an initial, as I remember from the Krebs report, we had a figure of 4% in badgers, but that was a wider sample. The difficulty is people tend to only look for TB in badgers where, not surprisingly, there's TB in the cattle. I mean, that's what, because of this issue of, so you can look at road traffic accidents over a much wider area, obviously, without involving any deliberate killing of animals, but there are issues with what state you get the carcasses in and how expensive it is to do that. But if you look in the initial proactive culls, we had prevalence that ranged from just a few percent up to 40%. And that was with the standard post-mortem. And as I mentioned, we know the relative sensitivity of that it was picking up 50% of infections. So there's probably twice that. That's indicative of those 10 areas. But I think the mean that Duffer's quoting is 16% based on the standard post-mortem, which would be equivalent of about 30%.
But no one's looked very hard. No one's looked very hard in areas where there's low cattle incidence, as Christl said, and I think that there have been some very sparse data reported from Scotland, which reported either 0 out of 200 or 300, or 1 out of 200 or 300 animals that were infected, even going back to a time when Scotland had TB.
Sorry, can I just ask one quick question? Yeah. The government's decided not to test any of the badgers, which seems quite a missed opportunity to find out what the incidence is and what actual benefit they're having.
Well, okay, but it won't tell you what the benefit to cattle will be. I mean, I think what they're relying on is the results from the RBCT, and that were achieved with a 70% reduction in population of the badger density. So therefore, aim this cull at achieving at least that much, and then you would predict to get at least the benefit observed in the RBCT. And I think their argument is that whatever prevalence they found in the badgers that were culled in this new cull, it wasn't going to change their ongoing policy. Scientists always like more data.
But it was going to add several £100,000 worth to the already high cost of the cull, which is the argument given by them for not. A massively missed opportunity. Absolutely couldn't agree more. Okay. But it's easy for me because I don't have to write the check. But yes.
But I don't think it would change their policy.
No,
I don't think going forward it would change.
But so one thing that we have the ability with more data on linked badger and cattle bovine TB isolates to do using modern genetic approaches to start trying to quantify the rates of transmission in both directions between the two different species. And there's been some preliminary work published from Northern Ireland, work done in Glasgow, in that area. And that's an area where we desperately need to expand the amount of information. And that's one way we can get a handle on the rates of transmission between the two species. And that could have provided insight in these two areas, but the suggestions got made too late before the budgets got agreed. So,
do you think there was anything political in that decision, though? I mean, I know it would cost more money, but being cynical, you would say that if it was found that a large proportion of the badgers being shot were actually TB-free, this would very much...
You'd expect the majority of them using the standard test, as Christl described. You'd expect the majority of them to be TB-free, and that's this is where culling, be it in a cage, a snare, or by a rifle, is a blunt instrument.
No, I mean, as scientists, I think we realised that it might be that killing badgers that had no TB at all could nevertheless have a knock-on good effect on the disease, but certainly in the public eye, could be a rather more simple interpretation, wouldn't there? Yeah. Julia, you had a question.
Relates to this. So if I were a policymaker, I'd be very interested in this 50% figure from Christl, because it would tell me the absolute best that could be achieved in TB reduction by wiping out all badgers, vaccinating them, whatever. That's the best case, right? But
it could be
Well, in the initial instance, I mean, but then you expect a feedback that if you take out the initial contribution to cattle from badgers, then those cattle will go on to infect fewer. Yeah.
Because I mean, the optimist would say that possibly TB can keep going in cattle, it can't keep going in cattle on their own, and can't keep going badgers on their own, and it's having the two together and interacting that is keeping it going.
That's why we need a two-host model that's
Yeah.
properly quantified, parameterized from real data.
Yeah.
this is the question. Those parameters are changing. You showed beautifully that it's the incidence, because we took our eyes off the ball, has increased dramatically over 2 decades. The data for your model come from the randomised badger culling trial, which was done in 2000.
It started, well, those initial calls would have started in 98, and the final one, the last 3 were in 2002.
That's a long time
So
ago.
3, yeah.
Could it be completely different for 50% now?
So, well, I would say the thing that would make me most question whether or not it could be different would be that they've since brought in pre-movement testing. To the extent that pre-movement testing reduces cattle transmission, then everything else being equal, then because you haven't affected the badger one directly, that might go up. But then I suppose you can make an argument that if the cattle are seeding the badgers, then that will have, yeah,
I
it
think
keeps going round and round.
I don't think that we can answer that question, and I think it's, and this is where I think as a group of quantitative scientists, we should be saying we need to do this in order to address that question. And I think the biggest, a question that I have is a challenge to those people who say this percentage matters or is insufficient, full stop. Actually, if the effect of badger culling overall is 13%, if that's the right figure nowadays, even given 10 years change, if the R0 value is 1.05, and we don't know what it is at the herd level, and we're talking about herd level statistics with that 13%, then actually maybe it is enough in a two-host system. This is where I think that actually 13%, if it was extended over, is conceivable, but we don't have the evidence to suggest that it is. It's conceivable that it could be way over the threshold effect that we need to bring the epidemic under control, which it's currently not.
I mean, obviously, there's a whole ethical
This
discussion
is
as well.
totally
Yeah.
outside of ethics, so this is just looking at numbers.
Yeah, so what would that achieve? But then, there are some people for whom I think 80% wouldn't be enough to want them
Or
to be
100%, yeah. Exactly.
in favor of badger culling, and just say, well, wild animals and farmed animals are our responsibility. We have to find a different way to deal with them.
But I think our responsibility as a scientific community is in this sort of science is to try and look dispassionately at the numbers, which Christl's been doing fantastically for 15 years. And I think that this is where these numbers matter, is for others to decide whether or not it's right or wrong, or too costly to look at this, particularly if farmers are paying.
So you're saying society should decide?
Again, sorry.
Yeah, can you tell us a little bit more about badger vaccination and whether it's feasible, and if so, why it isn't more part of the discussion?
Well, I think that a key issue at this point is that what's licensed is an injectable vaccine. So you have the expense of trapping the badger and vaccinating it. Now, people are saying that they'll volunteer to do this. There's, I think, a genuine concern that people who are against badger culling would be more likely to volunteer at this point when they feel like a policy decision is hanging in the balance, and maybe less keen next year and the year thereafter. But in that level, it's quite expensive. Now they're talking about trying to develop an oral bait vaccine. 2 issues with that. I mean, one, just getting it out to the badgers, and badgers' behavior is such that initial looks found that a few badgers got an awful lot of bait. And so there are various ways that you can try to handle this, like hiding it and making them look for it, but there may still be some that are just better at doing that. So, you may have to put out quite a few baits per bed, as opposed to being able to inject one, spray it with a bit of non-toxic paint, so you know that you've gotten that one this round and letting it go. But also, if a cow if you've got a vaccine and the cow eats the vaccine, that might well make it respond to the skin test, in which case you've caused your own false positive TB breakdown in cattle. So there are various issues that would need to be overcome, and they're non-trivial. But within badgers, the injectable one is looking quite promising.
A point that policymakers will make about the current badger vaccine is, while there is evidence that, whether it's 16%, 12% or 50% reduction of incidence in cattle can be produced by culling badgers, one of the things that we've got no evidence for at all is what the effect of vaccinating badgers can be on the cattle incidence. We know that it can be very, quite effective in protecting some badgers, and so there's a lack of direct evidence there, which exists for culling. So if you want science evidence-based, you could say there's stronger evidence for culling than there is for vaccination. Well, people will say that to you, to anyone who you ask.
All of those nonlinear effects that occur in regulating the densities would not be true?
No, I absolutely accepted. So you might think, well, if you can control it properly in badgers, then that will do the job. But I think a big part of that relates to how important the density reduction is against the incidence or the prevalence reduction in badgers, and that's something I don't think we fully understand.
The minister gave an interview over this period where I can't remember what day exactly, but said it was pointless to vaccinate an infected badger, which is true. On the other hand, it was used. Yeah, it doesn't hurt, and because that has been looked at, and the sort of implication then in the rest of the discussion was, therefore, it's pointless to vaccinate, which is not an approach that we take with other diseases that we might do. HPV, for example. But there is this issue, and I remember talking to a journalist who said, now you're being unscientific, because I said, you would expect if you reduce disease in badgers that would have benefits for cattle. Now I think, on basic epidemiological principles or common sense, as you would expect that. And because even with what we've learned about perturbation, you wouldn't expect that impact with vaccines, but I wouldn't want to say how much. And we also, we just don't, because we don't know these things. The average lifetime of badgers is about 5 years, to give you an idea of what the turnover would be. And they have cubs annually at pretty much the same day. So, you could imagine having an annual vaccination drive where you came and just, soon after badger cubs came above ground and they would get vaccinated. So, but you'd want to keep doing it every year.
Well, I think we've had a pretty good... One more question.
Sorry, I was just going to ask, with regards to the evidence for vaccination, that would come from the Welsh vaccination study eventually, do you think? Or are they again not collecting that?
Well, they've got one area. So they've got one area that they're targeting with both badger vaccination and with increased cattle controls. And they have accepted that they will not be able to disentangle those two things. To which the chief vet for Wales said, but it's we're trying to see if this policy works. And so that's what we're trying to test. But they're going to be looking for large-scale reduction. They're hoping for a large-scale reduction, not something that you're going to need randomized replicates for.
And there's an idea to try and do something similar in West Cornwall as well, with enhanced cattle measures, trying to combined with extensive badger vaccination, voluntary badger vaccination. And whether that gets off the ground will depend a little bit on money, but I think it's a great idea just to look at proof of principle. In areas where, because not all areas would be amenable to culling, even if you think culling's the best thing, or you have to do it generally. I think it's so I think that any measure that removes TB in the modern day, in this modern day, from a particular area is a success. That's what we need at the moment.
Well, thank you to all for coming, and thank you particularly to those who contributed to good lively discussion, and thanks most of all to our two speakers.